Hey, on this video we're going over the last two questions, questions 12 and 13 from the study guide. So in this first question, or both of these questions rather, we are given two different vectors that are going at angles, and we are asked to use the x and y component method to determine the resultant vector. So we're going to use this chart to help us with that. So these are kind of long to do, so let's get going. All right, so the first step you're always going to do is to draw it out. So we're going 20 meters at 40 degrees south of west. So that's going off this direction. It's going to touch the west axis, so that's where your 40 degrees is, and your magnitude is 20. Then you're going to draw this into a triangle, and then label the horizontal side x and vertical side y. So now we can use sine and cosine. So for this, x is adjacent, so we're going to use cosine. So we're going to have hypotenuse of 20, cosine of our angle of 40 degrees, and that will equal 15.32, and this is going west, so we're going to make it negative. Right? For y, it's opposite of our angle, so we're going to have 20 sine 40, and then we type that in the calculator, and we are going to get 12.86, and we're going to make this negative because it's going south. So anytime it's going west and south, you make them negative. So now we can plug that into our table up here. So negative 15.32 and negative 12.86. Okay, and if you round it to one decimal place, that's okay too. It's 1 to 2 decimal places is fine. Right? Then for the second one, we are going to sketch that one out as well. We're going 14 meters at 35 degrees south of east, or sorry, east of south. So it's going to go off like this and touch the south axis because south is second. So the 35 degrees will go here, and your resultant vector, or sorry, your hypotenuse will end up being 14 meters as your magnitude. So once again, we're going to turn this into a triangle. Sorry about that. We're going to go down and then over to make our triangle. All right, so it starts in the same place, ends in the same place. Your x is the horizontal side, y is the vertical side. So now x is opposite. So x we're going to use sine for, so it'll be hypotenuse of 14 sine 35, and that is going to equal 8.03. And we're going to keep it positive since this vector is going east. And then for the y is going to be 14 cosine 35, since your y vector is the one that is adjacent or touching your angle. And that is going to equal 11.47. And we're going to make that negative because once again it's going south. So now we can plug those into our chart and put the 8.03 in the x column, the negative 11.47 in the y column. Right? Now your next task is to add up each column. So the x column is going to equal negative 0.729 and then negative 24.33 in the y column. All right, let me clear off some space and we can finish the rest of this. All right, so now we want to turn this into a right triangle, and we're going to draw our totals are going to be our vectors. So the x column is negative, so that's going to go west 7.29, and then our y column is also negative, so that means it's going to go south, and it's going to be 24.33. And you can technically draw the y first. It doesn't matter the order. All right, I just always just do the x1 since it's written first. All right, so then your resultant vector is your hypotenuse, and from here it is a right triangle problem. So Pythagorean theorem, 7.29 squared plus 24.33 squared will give you r squared. Ultimately, when you work all of that out, you should end up with 25. At this time, that will equal 25.4 meters. Right? So now we want to find the direction that our resultant vector is going. So that's, since it's going at an angle, we need to find the degrees. And we can do that using inverse tan, or technically any of our trig functions, but I just always use tan because it always works. So inverse tan will be opposite side of 24.33 over our adjacent side of 7.29 will equal our angle, and that equals 73.3 degrees. And then we want to look at this and determine which way it's going, like north to west, east to south, that kind of thing. So if we put a compass here, we can see it's touching the west axis and it's going below that, so that'd be south of west. So to put all of the pieces together, we end up with 25.4 meters for our magnitude at a direction of 73.3 degrees south of west. Now, if you had drawn your y vector first and then your x vector, this time we need if you had drawn it opposite, your magnitude would be the same, and then your direction would be opposite. So it should be 90 minus 73.3 would give you the angle it should be, so about 16 point something. And then this would be reverse, would be west to south. Okay, so on a test, on a free response question, I would accept that other answer and just look to see that this is the opposite side, because it would be, you would draw it going this way. So it would be this angle right here that's complementary to it. All right, so let's do the next one. All right, same deal for number 13. Our first step is to draw it out. So we're going north of west, so we're going off like this. We're going 30 degrees, and 50 is our magnitude. All right, so then we turn it into a right triangle by going over and then up. X is horizontal, Y is vertical. So since X is adjacent, we're going to use cosine. So it would be 50 cosine 30. That's going to equal 43.3, and we're going to make a negative since it's going west. For the Y, it's going to be 50 sine 30, and that's going to equal 25, and we're going to leave it positive since it's going north. So this will plug into our chart. All right, now for the next one, we're going to draw that. We're going west of south, so we're down here, 65 degrees, and magnitude is 40. Sorry, that's kind of tiny. We're going to go down and then over. So X is horizontal, Y is vertical. So for the X is this time is opposite. So it's not always X is cosine. Sometimes X is sine. So it's going to be 40 sine 65. And that would equal 36.3. And we're going to make it negative because it's going west. And then for the Y is 40 cosine 65 since it's adjacent. And that is going to equal 16.9, and we're going to make that negative because it's going south. All right, so make sure you include those negatives, because if not, you're going to get the next part wrong. So we're going to plug those in, get negative 36.3 and negative 16.9, okay? Now our next step is to add up each column. We're going to get negative 79.6 in the X column and 8.1 in the Y column. All right, so let me clear some space now, and we'll finish this up. All right, so now we're going to take our totals and draw our new triangle. So we're going to go west 79.6, and we're going west because our X value is negative. Then we're going to go up 8.1. All right, let me move that 79.6. All right, then our resultant vector is the hypotenuse, and you have your right triangle. All right, so then we want to do Pythagorean theorem. So 79.6 squared plus 8.1 squared equals r squared. When we work all of that, we should end up with 80 for our value, okay? Then we want to know which way it's going, so we're going to use inverse tan to find the degrees of our angle. So opposite side is 8.1, adjacent side is 79.6 to get our angle, and that's going to equal 5.8. So this is actually a really, really narrow angle, okay? And then we need to know the compass part of our direction, so we can see that this is touching the west axis and it's going above it, so north of west. So then to put everything together, our magnitude is 80 meters at 5.8 degrees north of west. And just like I said on the last slide, if you had drawn this opposite and gone Y then X, your magnitude stays the same, but this will be reversed. So this would be the complementary angle. So this minus 90 would, or 90 minus this would get you the degrees you would get, and then these would be flipped, okay? But I'm looking for these to match. So if you say 5.8, you need north to west. If you give me the complementary angle, it should be west to north, okay? But if you've got any questions, you're still not sure, just let me know.